So this is part 2 of 3D equilibrium of a particle. So levels 6 to 10. The smooth homogeneous sphere rests in the 120-degree groove and bears against the end plate, which is normal to the direction of the groove. Determine the angle theta measured from the horizontal, for which the reaction on each side of the groove equals the force supported by the end plate. So the condition, the reactions on each side of the groove is equal to the reaction at the end of the plate, which is here. So let's draw first the FBD of this groove in this direction, not in this inclined plane, but in this direction. It looks like this, like that. So the weight is not purely W, but it is inclined here by an angle theta. So this is W cosine theta. And we have equal reactions on each side of the groove if you look at it from here, from this view, RG. So this angle is 30 degrees each. So that 2RG cosine 30 equals W cosine theta. Or to better look at it in this view here, so we have the weight, we have 2RG cosine 30 degrees, which is this 2RG cosine 30 degrees vertical. RV vertical is 0. So RG cosine 30 times 2, which is this, equals W cosine theta, because this the angle that W makes with this normal axis is theta also. And this is the end reaction, and that is theta. That is why if you set R normal equals 0, then the normal component of W is W cosine theta, which is this. So that's why this is 2RG cosine 30 from this view here equals W cosine theta. And R normal equals 0, so we then set up 2RG cosine 30 minus W cosine theta, which is this component, equals 0. So 2RG cosine 30 degrees equals W cosine theta. Then we are given the condition that RG equals RE. That's the condition of the statement here. Then R tangential equals 0. So RE, which is RG, is positive, then minus this component of W, which is W sine theta. So it is equal to RE minus W sine theta. Therefore, RE is, which is equal to RG, is W sine theta. Then we draw the force triangle. We have, for this free body diagram, we have W. Then this one is 2RG cosine 30 or W cosine theta. And this one is RE, which is RG, equals W sine theta. So we do not use W sine theta and W cosine theta because tangent of theta is W sine theta over W cosine theta. That is equal. That is an identity. Instead, we use the reactions. Tangent theta is RG divided by 2RG cosine 30 because this angle is 90 degrees. This is perpendicular to the inclined plane and this is parallel to the plane. That's why these two forces are perpendicular. So we define in this right triangle tangent theta, which is RG divided by 2RG cosine 30. So we cancel RG. 2 cosine 30 is 2 times square root of 3 over 2. So this reduces to tangent theta is 1 over square root of 3. And inverse tangent of 1 over square root of 3, theta is 30 degrees. So theta is 30 degrees. So level 7, a smooth homogeneous sphere of mass m and radius r is suspended by a wire AB of length 2r. From point B on the line of intersection of the two smooth vertical walls at right angles to one another. So determine the reaction big R of each wall against the sphere. So here is the given figure. Take note that AB is 2R, then plus length of or plus radius of the sphere. So from the center of the sphere to B, the total length of that length would be 3R. So let's draw the free body diagram of the center of the sphere and the axis, and as well as the tension and the reactions on the walls at right angles. So this is the X, Y, and Z. So here we have mg, the weight of the sphere, then tension, because the tension passes through the center. The total length of this is 3R, 2R length of string plus radius of the sphere, so 3R all in all. Therefore, tension AB is directed opposite to X, R, because that's the radius of the sphere. Then against opposite to the y-axis, R also, radius of sphere, then delta Z. So these are the reactions, equal reactions at the walls, R and R. Then that's delta Z. So delta Z, hypotenuse or length 3R quantity square equals R square plus delta Z square. In other words, the components of distance of tension AB are R to the opposite to X, R opposite to Y, then delta Z along Z, upward. So delta Z is R square root of 7, because 9R squared minus 2R squared is 7R squared, so extract the square root R square root of 7. Then RZ is 0 to solve for tension AB first, and it is equal to the positive component of tension AB is tension AB times component of distance delta Z, which is R square root of 7, divided by distance, which is 3R. So R square root of 7 over 3R, the distance from center of sphere to B. Instead of square root of R square plus delta Z square, it will go back to 3R. Then minus mg. So therefore, cancel R. Tension AB is 3 mg over square root of 7. Then Rx equals 0, or you may use Ry equals 0, but because the reactions are the same, R. So this is positive, equals R, then minus the X component of TAB, which is TAB times, it is negative because it is opposite to x-axis. So minus TAB times R over distance 3R. So R0 equals R minus tension AB 3mg over square root of 7 times 1/3 after we cancel R. So we cancel 3. R therefore is mg over square root of 7. So that's the reaction to each of this wall here. This level 8 problem is considered a very challenging problem, but since it is assigned here, so let's just accept this problem. 3 identical steel balls, each of mass m, are placed in the cylindrical ring which rests on a horizontal surface and whose height is slightly greater than the radius of the balls. The diameter of the ring is such that the balls are virtually touching one another. A fourth identical ball is then placed on top of the 3 balls. Determine the force P exerted by the ring on each of the 3 lower balls. So this is the figure. I'm sure that most of you will just ignore this problem when you see this, especially when there are no dimensions. But this is a very nice problem for those who want to study statics, because it will test your analysis and skills. You will not succeed you will not be good in statics if you just ignore problems like this. And there will be another problem which is very challenging also, maybe in level 15. So for the solution, let's study the upper sphere. Then imagine the center to center of these lower horizontal spheres, and it forms a regular tetrahedron of length 2r, 2r, and 2r. So by symmetry, the reactions between the upper sphere and the three lower spheres will be equal. So because this is a regular tetrahedron, and the base is also a regular tetrahedron, which is 2r also, if you connect center to center of the sphere. That's why this is a regular tetrahedron. So this is the weight of the upper sphere, which is mg. They are identical. Then the base 2r equilateral triangle also. So we connect a line from here to the midpoint of this side, which is the height of the equilateral triangle. So we drop this, and this is the centroid of the equilateral triangle. And the centroid of the equilateral triangle is located 2/3 of the height of the equilateral triangle. If we denote the height, so that's perpendicular there. This is r, this is hypotenuse 2r. So we can compute the height as square root of 2r quantity square minus r square, or you can also say height h1 is 2r sine of 60 degrees. So the reactions will be the same, R1, R1, R1. They are equal because of symmetry. The reaction at the contact points between the upper sphere and the three horizontal spheres. So that is H1, and this is 2/3 of H1 because that's the centroid, and that's 90 degrees also. So H1 is, so let's call that height from the centroid of the base to center of the upper sphere, this one. So H1 is 2r sine 60 degrees, or square root of 2r quantity square minus r square. So simplifying, H1 is r square root of 3. Then the distance from this vertex to that is 2/3 of H1 because this is the centroid of the equilateral triangle. So 2/3 of H1 is 2/3 of r square root of 3. So that we can now solve for H, the vertical component of distance of R1. Each of these reactions R1. So H is square root of 2R square, hypotenuse square, minus 2/3 of H1, which is 2R, 2/3 of R square root of 3 square. If you simplify that, that's 2R square root of 6 over 3. So that R vertical equals 0. And therefore, the positive component of R1 is multiplied by vertical component of R1 is multiplied by 3 because there are 3 reactions, because there are 3 lower spheres and they are equal. So 3 equals 3 R1. Vertical component of distance is 2R square root of 6 over 3 divided by distance, which is 2R. So 3R1, vertical component of distance 2R square root of 6 over 3 divided by distance 2R. Then minus mg. So cancel 2R, cancel 3. What remains here is R1 square root of 6. Therefore, R1 is mg over square root of 6. So having found R1 mg over square root of 6, then we now transmit R1 to the one of the lower spheres so that we can analyze for this reaction contact force P with the ring. So this is the lower one of the lower spheres of the 3 lower spheres. Then we have R1 here. So remember, the horizontal component of distance is 2/3 H1 and the distance or the length is 2R. Then we have normal reaction here at the bottom, and the contact reaction between the ring and the one of the lower spheres, which is denoted by P because it is denoted P here. So to solve for P, we set in this free body diagram R horizontal equals 0. This is in equilibrium. So P, so equals P minus horizontal component of R1 is R1 times 2/3 of H1 divided by 2R. Horizontal component of distance divided by distance, which is 2R. So cancel 2R again, replace P. So P is R1 mg over square root of 6 times square root of 3 over 3. So simplifying, P can now be computed mg over 3 square root of 2. So that's the value of P. Three cables are used to tether a balloon as shown. Determine the vertical force P exerted by the balloon at A, knowing that the tension in cable AD is 481 newtons. So here is the figure. So take note that the tension is downward in the cable at A. So P is upward as shown. So let's express each cable tension into vector form so that we can easily add their corresponding components later and set to 0. So tension AB first. So take note the orientation of the axis is different. Tension AB in vector form is magnitude of tension AB times negative 4.2I negative 5.6 J over square root of 4.2 square plus 5.6 square. Simplifying, tension AB is magnitude of tension AB times negative 0.6I negative 0.8 J. Next is tension AC. So it is tension AC in vector form is magnitude of tension AC, then quantity 2.4I, negative 5.6 J, then positive 4.2 K over square root of 2.4 square plus 5.6 square plus 4.2 square. Simplifying, tension AC is magnitude of tension AC 12 over 37I minus 28 over 37J plus 21 over 37K. And lastly, tension AD, the magnitude is given. So tension AD in vector form is 481 quantity and negative 5.6 J, then negative 3.3 K over square root of 5.6 square plus 3.3 square. Simplifying, tension AD is negative 414.4 J minus 244.2 K. So to get rid of simultaneous equations, we then set supposedly RZ is 0 so that we can solve tension AC right away because there are only two unknowns here, tension AB and tension AC. Tension AB has no Z component, but let's have Rx first equals 0. Then next RZ later. So negative 0.6 tension AB plus 12 over 37 tension AC. Then there's no X component for tension AD, so we can express tension AC in terms of tension AB. Tension AC is 0.6 times 37 over 12 tension AB. So it is 1.85 tension AB. Tension AC is 1.85 tension AB. Then RZ is 0 so that we can solve tension AC. So 21 over 37 tension AC minus 244.2 equals 0. So we can now solve tension AC. Tension AC is 244.2 times 37 over 21. So 430.3. Substitute here to solve for tension AB. 430.3 is 1.85 tension AB. So tension AB is equal to 232.6 newtons. Finally, RY. vertical equals 0, and it is equal to positive P minus 0.8 tension AB, then minus 28 over 37 tension AC, then minus 414.4. Now substitute P. P therefore is equal to the transpose this to the left, so they are all positive. So P is 0.8 of tension AB to 32.6 plus 28 over 37 of 430.3 plus 414.4. So we can now solve for P, and it is upward. So the answer is 926.1 newtons upward. Without that upward, that is partially wrong. Or you may answer in vector form P 926.1 J newtons. That's also the other possible answer. Level 10, a container of weight W 1165 newtons is supported by 3 cables as shown. Determine the tension in each cable. Here is the given figure. So as usual, we express each cable tension into vector form. Beginning with tension AB, take note the weight here is along Y, so 1165 negative 1165. So tension AB is equal to magnitude of tension AB, quantity 0.45 I, positive 0.6 J over square root of 0.45 square plus 0.6 square. So let's change 450 mm all these dimensions to meter to shorten the solution. So simplifying, tension AB is magnitude of tension AB times quantity 0.6 I plus 0.8 J. Then tension AC, no X, so it is magnitude of tension AC plus 0.6 I minus 0.32 K. So tension AC, quantity 0.6 J minus 0.32 K over square root of 0.6 square plus 0.32 square. Simplifying, tension AC is magnitude of tension AC times 15 over 17J minus 8 over 17K. Next, tension AD. So tension AD is magnitude of tension AD negative 0.5 I plus 0.6 J plus 0.36 K over square root of 0.5 square plus 0.6 square plus 0.36 square. Simplifying, tension AD is magnitude of tension AD times negative 25 over 43I plus 30 over 43J plus 18 over 43K. Then set Rx 0 for systematic solution. Then we have 0.6 tension AB minus 25 over 43 tension AD. So tension AD is 0.6 times 43 over 25. Tension AD is 1.032 tension AB. Next, set Ry equals 0. Then we have 0.8 tension AB plus 15 over 17 tension AC, then plus 30 over 43 tension AD, then minus the weight, which is 1165. So replacing tension AD here by 1.032 tension AB and transposing this to the left. So 0.8 tension AB plus 15 over 17 tension AC plus 30 over 43 of 1.032 tension AB equals 1165. Simplifying, combining tension AB, so we have 1.52 tension AB plus 15 over 17 tension AC equals 1165. Call that equation 1. Finally, Rz is 0, and it is negative 8 over 17 tension AC plus 18 over 43 tension AD. And from there, tension AD is, tension AC in terms of tension AD is 18 over 43 times 17 over 8. So tension AC is 153 over 172 tension AD. Substitute the value of tension AC in equation 1, which is in terms of tension AD, and tension AD in terms of tension AB, so that we can solve for tension AB. So 1.52 tension AB plus 15 over 17 of tension AC, which is 153 over 172 of tension AD, and tension AD is 1.032 of tension AB equals 1165. So therefore, tension AB is 1165 divided by quantity 1.52 plus fraction 15, 153, 1.032 over 17 over 172. And you'll get tension AB equals 500 newtons. Next, tension AD, which is 1.032 of 500. So tension AD is 516 newtons. Then finally, tension AC, 153 over 172 of 516 tension AD. So tension AC is 459 newtons. So that's it for this problem.